Ionic bonding and periodic properties. Teaks C.6b, C.7a, and C.7d. After this lesson, you will be able to construct an argument to support how periodic trends, such as electronegativity, can predict bonding between elements, analyze the properties of ionic substances in terms of intermolecular forces, and describe the structure of ions. Previously, you learned that the chemical and physical properties of elements are largely determined by the number of valence electrons in an atom. Valence electrons may be lost, gained, or shared to form new substances. Ionic bonds are formed between two or more atoms when electrons are transferred, producing a negative ion called an anion and a positive ion called a cation. This electrostatic attraction between these oppositely charged ions creates an ionic bond. Electronegativity is the ability of an atom to gain or attract electrons. Notice the trends in the periodic table. Fluorine has the highest electronegativity value, and francium has the lowest. We can use this information to predict whether the two atoms will share electrons, forming a covalent bond, or they will lose and gain electrons to form an ionic bond. Scientists have determined that the difference in the electronegativity of 1.7 or greater between two atoms typically results in an ionic bond. Let's practice your understanding of calculating electronegativity differences to determine bond type. Calculate the electronegativity differences for each pair of elements below. Which pair or pairs would most likely form an ionic bond? Carbon and oxygen, sodium and bromine, phosphorus and hydrogen. Teachers, please pause the video to allow time to answer. If you chose sodium and bromine, you would be correct. Sodium and bromine have an electronegativity difference of 2.03, which causes them to form an ionic bond. Carbon and oxygen will form a polar covalent bond due to an electronegativity difference of 0.89, and phosphorus and hydrogen form a nonpolar covalent bond with an electronegativity difference of 0.01. Notice that sodium and bromine are the only pair in which there is both a metal, sodium, and a non-metallic bromine. Ionization energy is useful for determining if an atom will form a cation or an anion. Ionization energy is the minimum energy required to remove one valence electron from a neutral atom or molecule. Because metals have low ionization energies and low electronegativities when compared to nonmetals, they tend to lose electrons more easily to form cations. For example, sodium, an alkali metal, has one 3s valence electron. Losing its valence electron gives sodium a full octet of electrons in the second energy level, making it more stable. Once the sodium atom loses its single valence electron, it now becomes a cation with a +1 charge. Its new electron configuration will be identical to neon. Nonmetals, because of their higher electronegativity and ionization energy, tend to gain electrons to form anions. Fluorine, with its high electronegativity, is extremely reactive. Gaining a single electron gives fluorine a full octet of valence electrons, making it more stable. When the fluorine atom gains an extra valence electron, it becomes an anion with a -1 charge. Its new electron configuration will be identical to neon. Ionic bonds are formed when valence electrons are completely transferred from a metal to a nonmetal, creating oppositely charged ions that attract each other and form electrically neutral compounds. For example, when sodium loses its valence electron to chlorine, a cation and anion are formed. Strong electrostatic forces of attraction between the oppositely charged ions form an ionic bond and create a neutral compound known as sodium chloride.